All right, it's 11:01 on Thursday morning, the 9th of November, 2017. It's supposed to be linear algebra time, and right now I'm the only one in the room, so I hope the others will be coming soon. And let's get started on today. Let me go through a couple of announcements. First, yes, this one, said it last time, I believe, too. Tomorrow, Friday, the 10th of November, is when the state has chosen, or at least the system or our college has chosen, to give us the holiday for Veterans Day. Veterans Day is actually the 11th, which is Saturday, but because that's on a weekend, they're giving us Veterans Day holiday for tomorrow. So if you had class tomorrow, don't come, okay, because the college will be closed. If you had planned to take care of some business or get advising or counseling or anything else, don't bother coming. The college will be closed. No one will be here except the skeletal police force, and everybody else, the college is closed. Probably have the gates closed too, I don't know for sure. Probably the building's locked up, don't know that for sure. But I'm not going to be here, no one else will be either. Okay, so that's number one. Number two, I think you may have recalled, hopefully you will, that back toward the end of September, 1st of October, I was telling you as we were approaching the end of the first mini-term that sometime the next week after the midterm passed, which was when the first mini-term was over, they usually had on the academic calendar that week we were supposed to submit midterm progress reports. But I said sometimes they don't open them up for us, so we can't submit them. Or they don't tell us that we can anyway. So they didn't, so I didn't. And then this week, they decided to do midterm progress reports. So I think they were due either yesterday or today. I did them yesterday. So if you had a D or an F at midterm, or as of yesterday, then I indicated that on the midterm progress report. Things to improve that, of course, would be get your research paper in if you haven't done that already, and also the additional test. I think y'all all have one test out. Both of you have one test out. I think one of you has turned in one research paper, and both of you have turned in the first test, but neither of you have turned in the second test, and we're very close to the point of me giving you the third test. It's ready to distribute. In fact, I may have even given it to one person. No, I don't think I did. Okay. All right, so there's that. I think I asked both of you, and neither one of you will be here in the fall. You're both graduating or finishing or moving on or whatever after spring. So I was going to encourage you to participate in the math team, but you won't be here. And then the last thing was coming up on December the 12th, which is a Tuesday, second Tuesday in December. Not a normal voting day by any stretch of the imagination. Second Tuesday in November, often a voting day, and there were some elections across the country earlier this week, day before yesterday, but none in Alabama. But we do have a special election coming up December 12th. That's to select the senator that will replace Jeff Sessions. Now, the former governor had appointed Luther Strange, but that wasn't done properly. It wasn't supposed to be an appointment, it was supposed to be an election. And when the former governor got ousted and the lieutenant governor became governor, she said, nope, that wasn't done right. We need to have elections. So they had primary elections, a runoff of one of the primary elections. So now we're ready to elect the senator. And that election will be Tuesday, December the 12th. I am really big on voting every time the polls open. Okay, so I want to highly encourage you to vote. If you're 18 years or older, and you are not registered yet, please register. You still got time to register now and still be eligible to vote in December. That's why I'm saying this now. If you are registered to vote, please make sure you know where your polling station is and plan to be there to vote. And the reason I say this, these off-time elections like this are often very low turnout of voters, very low turnout, disgustingly low turnout. I mean, we have low enough turnout in a regular general election, but these are really poor. So my wife did some figuring on it. In the primaries, the candidate who had the most votes in either of the two primaries had around 8% of the registered voters voted for that person. 8% decided who was going to run for Senate. That is not right, okay? We really, your vote will never count more than it will in this election because so few people will vote. You could make a difference in the election if you vote. So please, folks, plan to vote on December 12th. I'm not going to tell you who to vote for or for whom, or how to vote or anything else. I just want you to get into the habit of voting. So please do. Don't let a small handful of very dedicated people determine who the senator for this state is. It needs to be the majority of the citizens of the state. It's probably not going to happen, but we need to get as close to that as possible. Please vote. You can make a big difference. So please vote this coming up in December. Okay? All right. Enough of that. Let's move on to Chapter 3, Determinants, 3.4, Applications of the Determinants. This is a different kind of application. Last time we talked about Cramer's rule and using that to solve systems of equations. Not an efficient way, but certainly another way to do that. And it's also relatively easy to program to do that. Okay, say a computer or something else. Now we're going to look at area and volume and equations of lines and planes. Okay? You might think, what in the world does a determinant have to do with that? Well, this is just another application in analytic geometry of where you can use a determinant. Okay? And here's what we do. If you're trying to find the area of a triangle in the XY plane, so you're on two space here, XY plane, you got a triangle there. Triangle has three vertices. Let me get my pen activated here. Okay. Let's say one vertex is x1, y1, very cleverly named. Another vertex, x2, y2. And guess what? The third vertex we'll name x3, y3. Okay. Now, just happens to be the area of this triangle formed by those three vertex is equal to, now this looks strange at first, plus or minus, okay? That looks bizarre to have that there. The determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay. Why the plus or minus sign in front of the determinant? Well, a determinant is either going to be positive or negative. Okay? Now, it can be 0, but if these 3 points are not, that all 3 of them are not on the same line, or no 2 of them are exactly the same 2 points, or anything else such as that, if these are 3 distinct points not collinear all with one another, then this will not have a determinant of 0. Okay? So that's out. But it'll either be plus or minus. If it's plus, if the determinant is plus, you use the plus. If the determinant turns out being negative, use the minus sign, because your area is always going to be positive. So that's the only reason the plus or minus is there. Okay? Now, they do give a proof for this, and do my best shot to replicate that proof. For this purpose, let's assume this triangle is in the first quadrant, okay? Somewhere here in the first quadrant. And here are your 3 points. That one would be x1, y1. This one up here over here will be, doesn't matter, but x2, y2. And this one up here will be x3, y3. Okay? Now here will be the triangle in question. If I could draw, I'd do a better job of drawing. Okay, there's the triangle. What we're looking for is the area of that triangle. Okay? Now, what they do is draw a construction line here down to x1. Okay? Draw another construction line down here to x3. Another construction line down here to x2. Okay? And we're really not too concerned with the y's here, much at all. Okay? Now here's the thing to note. Here we have between x1, the point x1, y1, the point x3, y3, the point x3, and back to x1 again, you've just outlined what we call a trapezoid. Okay? It's a trapezoid. Now, I wish I could go back to my previous thing. I think I forgot to put in my 1/2 there. It's 1/2 the determinant that we had before. But I can't go back, so you'll have to go back and change that. It's 1/2 plus or minus 1/2 the determinant of that. Okay? I can't remember if I put my 1/2 in or not. But the area of a trapezoid, okay, would be the y1 height here, okay, plus the y3 height here, and divide by 2, okay, which would basically be giving you the average of those two. And the okay, and here's why the average works for us. This area here is exactly the same as that area there. Okay, so that is the area of this rectangle now is the area of that trapezoid. Okay, so it's the area of that trapezoid is 1/2 x1 plus x3 times x3 minus x1. That's the length here. Okay? The area of this trapezoid over here, made from the vertex x3, from x3 up to the vertex x3, y3, down to x2, y2, down to x2, and then back. That trapezoid, its area is the average of x2 of y2. Okay, sorry about this. Earlier I said y, and then I wrote x. Okay. This is y1 plus y3. Okay, I said it earlier correctly, and then I wrote it wrong there. It's the average of y1 and y3 that gives you this average right here, and that area times the difference between x3 and x1 as the base. Okay, so over here the average between these two, which would be here, and this area and that area are the same, so this trapezoid here would be 1/2 y3 plus y2 times x2 minus x3. Okay? Then you subtract off this trapezoid at the bottom between x1 and x2, going up from x1 to x1y1, over here to x2y2, down here to x2, and then back to x1. So that trapezoid you subtract off would be 1/2. The average there, I have them looking awfully close to each other here. So it would be a little bit shaved off here, a little bit shaved off here, this area and that area the same. So, be 1/2 the y1 plus y2 times x2 minus x1. Okay. Now, if you were to first factor out the 1/2, okay, so you're subtracting this one from the sum of these two, okay? And if you were to work that out, first thing you do is factor out the 1/2, okay? And then the next thing you do, you multiply everything through and across and back and forth like that. And what you wind up with is a bunch of things which happens to turn out exactly the elements of that determinant. Okay? Now, they show this more in the book. I'm just sort of giving you a graphical view of it. And if you were to subtract that, and they show these exact things here, now what to do here, remember that determinant we had, that row of ones, let that be the row you multiply through, okay, that you use to determine your determinant. Go down that one and you'll notice if you're in the 1,3 position, then you do x2y3 minus x3y2, okay? x2y3 minus x2y3 minus y2x3. x2y3, there that one is, minus y2x3. And there's that minus, okay? And if you went to the next one, that would be a minus x1, y3 minus a minus would be a plus y1, x2. X, like I said, minus x1, y3 there's your minus x1, y3 plus y1, x3, which was a minus. So there's that term. And if you go to the third one, the 3,3 position, and do your determinant there, you get an x1, y2 minus x2, y1. x1, y2, that would be these minus that. Okay. Now, those are just a few terms. What happens to the rest of them? Well, let's just say your x1, y1s, here we have a minus here, there we have a plus here, okay? Here we have a x3, y3, and here we have a minus x3, y3. So you see the rest of them that we haven't accounted for so far are going to disappear. Here's a x2, y2, and there's a minus x2y2. Okay, so every other one, and I didn't write all these out. Number one, I don't have room. Number two, it would be such a huge mess to do, and then keeping up with them. But sure enough, half of them disappear because they cancel each other out, and the others wind up being exactly what we've got here. Okay, let's now move on to example 5. That's how we get that. Let's actually use it. Okay? Find the area of the triangle whose vertices are, and you don't really even have to graph it. Well, maybe this one you do. Okay? And they gave you all positive points, so it'll be in the first quadrant. Here is 1, 0. Okay? 2, 2, there's 2, 1, 2, there's 2, 2. And the next one is 4, 3. 3, 4, 3. Oh, yuck. Off a little bit here. I don't know. My drawing is part of the problem. And the other thing, these happen to be 4, 3. Okay? If you'll notice this, to get from the first to the second one, no, I haven't drawn it well. My intuition was right. I was looking at the wrong. Yuck. Well, I got one of those right. Okay. 2, 2 would be about right here, and 4, 3 would be here. So sure enough, this is a triangle. Okay? 1, 0, 2, 2, 4, 3. Okay. Says find the area of the triangle whose vertices are that. Well, doesn't matter which order you do them or anything else, but the 1/2 plus or minus 1/2 the determinant of, and that would be 1, 0, 1, 2, 2, 1, and 4, 3, 1. Okay. Now this time, let's not go use the 1 column. I would say use that top row. That's going to be the easiest thing to use as a determinant. So that's going to be this position, the 1. Okay. Mark out the first row, first column, and positive 1 times the determinant of 2 minus 3, that would be a negative 1. Okay? All right, let's wipe out. Well, okay. Then let's go to the third column, and that's going to be a position positive, so it's going to be a 1 again. 6 minus 2 minus 8 is a minus 2, so this is a negative 3. Okay? So the determinant of that array, if I did it right, was negative 3. Well, half of that would be 3/2, and take the minus of that, that would be an area of 3/2. Okay? And as you see, that's a pretty small area because they're fairly close to each other, and sure enough, that's what, well, the determinant is negative 3. Negate that, make it a positive 3. Multiply that by 1/2, and you get 3/2. We conclude the area is 3/2 square units. Okay. Now, what I thought was the illustration for that one is really a different illustration. And let's do this one. Okay, what if our 3 points, rather than 1, 0, was a 0, 1? Zero, 1. Two, 2. And 4, 3. All right. That case, we have a straight line. So what's the area of a straight line? 0. Okay? It has no area because it's not enclosed. It's just a straight line. These 3 points are collinear. I'm sorry, but I'm trying to warm my hands up. It's just frigid in this room. Well, not frigid, but very cold. Well, you expect that determinant to come out 0. Let's see if it does. That's 1/2 plus or minus the 1/2. The determinant of 0, 1, 1, 2, 2, 1, and 4, 3, 1. All right. Now, it's not obvious that any row or column is a multiple of the other. Okay? I was sort of thinking that would turn out being the case. It's not. But if you do the determinant, you still do that. And I think, again, I would go with the first row here. The 0 contributes to nothing. That 1 is in a negative position, so that's going to be a -1 times 2 minus 4, so that'll be a -2. I'm sorry. 2 minus 4 is -2. Okay. Plus 1. Yuck. Oh, man. I don't know what happened to it. Must have hit something that deleted it. But I can't get it. No! This is doing all sorts of weird things. Okay. I'm not going to redraw it. I'll have to rewrite it here. And my pen is... This is so bizarre. Okay. This 1/2 is really plus or minus 1/2 of the determinant of 0, 1, 1, 2, 2, 1, and 4, 3, 1. Okay, let's do the first row here, and this will be plus or minus 1/2 times. The 0 gives you nothing. Okay, the next one is going to be a -1. It is a 1, but it's in a minus position, and that will be 2 minus 4, which would be a -2. Okay? All right. Let's go to the third one here, which is in a positive position. Oh, wait. Just want to erase this construction. Goodness gracious, this thing's a pain in the neck today. The eraser's not coming up. There it is. Okay. All right. Wipe out that. The third one, that's in a positive position, so that's plus 1 times 6 minus 8 is negative 2. What do you have then? Plus or minus 1/2 times 2 minus 2. That's equal to 0. All right. So, sure enough, even when they're collinear points, all points on the same line, it gives you correct answer that your area is 0 because there is no area there. So it doesn't have to be 3 vertices of a triangle. They could be any 3 points. If they're collinear, the area is 0, and that sure is what they give you. So you don't need plus or minus there at all. Okay. So if 3 points in the xy plane lie on the same line, then the determinant in the formula for the area is 0. So this leads to the following result. So let's go on and delete that. I tell you, this room is so cold that my nose is beginning to run and throat's beginning to hurt, the whole 9 yards here. 3 points, x1, y1, x2, y2. So you got the 3 points, x1, y1, x2, y2, x3, y3, are collinear okay, my writing really stinks here. That's collinear. All right. Quit looking at what I'm writing. This is if and only if. Now, there's a couple of ways to write that. One way is IFF. You can spell it all out too. Another way is the arrow symbol that goes both ways. It's true if this is true, the right-hand side is true. If the right-hand side, then the left-hand side is true. That's why it's double if and only if. Collinear if the right-hand side is true. The collinear only if the right-hand side. Okay. So that then the determinant, I don't like writing that. Let me just write the straight lines. X1, Y1, 1, X2, Y2, 1, X3, Y3, 1. If this is equal to 0. Okay? So that's how you tell if 3 points are collinear. Take the determinants. Not just the determinant, you have to have 1 in the third column. Okay? Now you can also adapt it for another use. That is, if you are given 2 points in the xy plane, you can find an equation of a line passing through those 2 points. Okay? And this is all different applications of the same idea here. An equation of a line okay, passing through 2 distinct points. Now what does distinct mean? Not the same point, okay? Distinct point x1, y1, goodness gracious. Yeah, my hands are so cold. x1, y1, and x2, y2. x2, y2. 2 different points. Okay? It's given by, and you do the determinant. Okay? Only the top row we do x, y1, variables x, y, 1. Second row, you do x1, y1, 1. And the third row, you go on x2, y2. All right. If that determinant, it's falling on me, is equal to 0. Set that determinant equal to 0. Okay? Now, I had my 1s there, and then goodness gracious, this pen is not doing at all what I asked it to do. Okay. Start over now. Okay. So what you would have then is, for your x, you would have y1 minus y2x plus y minus x, x2, 1 minus x2. I'm so glad you're here. Goodness gracious, I've been in here freezing. If you could bring a fire with you, that would be good.
I need to wear this space for people anyway.
Yeah, goodness gracious. And it's gotten cold outside, so it's even colder in here.
I'm going to wear one next
I've been sitting here wanting to keep my hands over the fan here because it gets so cold, but I can't because I need to be writing. Oh yeah, flip the lights and turn on the projector. I've seen this a couple of places. Oh, that's the NASA community job. It's going to take just a couple minutes of the projector to get bright enough to read. We're on page 133. We've done a couple of different things, how you determine the area of a triangle in the xy plane given the 3 vertices using determinants. Test for collinear points in the xy plane, use the determinant. If the determinant is 0, this special determinant. And then the third one is, if you're trying to get an equation of a line given 2 points, set that determinant 0, and that's what we were just doing here. This time, the third row is not a third point, it's just the variables x, y, 1. Then your 2 points, x1, y1, 1, and your second one, x2, y2, 1, and then calculate this determinant and set it equal to 0. Okay? Now, example 6 is going to do that for us, so that's the how you do it. Here is actually doing it. Okay? So, second? 3.4, that's correct. Okay? So, all right, to erase. Okay. So here's example 6. Find an equation of a line passing through these 2 points. Now this is in the xy plane. This is not in xyz space. Xy plane. Points 2, 4 and -1, 3. And we know there's one and only one straight line that passes through those 2 points. What's the equation or formula for that? Okay, the equation of the line passing through those. Well, what the last thing told us was you set up a determinant. The top row is going to be x, y, 1. Okay? You might say, why 1? Because it works. Okay? And then you put the 2 points there. It doesn't matter what order. We'll just do them the way they gave them. 2, 4, 1, and -1, 3, 1. Okay? And you set this determinant equal to 0. That's going to guarantee these are going to be on a straight line with the other point x, y. Okay? So let's do the determinant. Now, it doesn't matter which row or column you use. It just seems like to me in this case the easy one would be that column of ones. Okay, so let's use that one. Okay, for the first entry, we'll use that top one. You're going to wipe out this, and that gives you your constant. This is a positive here, positive 1. What positive position there? Plus, minus, plus. And you do the determinant here to be 6 minus a minus 4, which would be 10, right? 6 plus 4 is 10. There's a constant, okay? Now, let's erase that construction line and these two, and let's go to the yuck. This has been doing strange things. I don't know why it's doing this. Okay, we'll wipe out the second row. That's in a negative position, that one. So it's going to be a minus, and then do the determinant here, 3x plus y. You see that? Because minus a minus y. But you got a negative in front of that. Okay? There's your minus y. Minus y. Okay? And then your third one was wipe out these construction lines and wipe out the third row. And that one is in a positive position there, so that's going to give you plus 4x minus 2y. Okay? Now, and that's equal to 0, because you said that determinant had to be equal to 0. Well, here you have a plus 4x minus 3x, so that's just going to leave x. Okay? Here you have a minus y minus 2y, so that's minus 3y. And this other one is plus 10 is equal to 0. Okay. Now that is a perfectly good, goodness gracious, equation of a line. If you wrote it in what they usually call standard form, it would be x minus 3y is equal to negative 10. It doesn't really matter how you write it. It's not in slope-intercept form because that's just not handy here. But let's see if both of those points work. If we put a 2 in here and a 4 in here, that would be, or up here either one, it doesn't matter. That would be 2 minus 12 is minus 10. If we put a negative 1 in here and a 3 there, that would be negative 1 minus 9 is minus 10. Sure enough, that's the equation of a line that contains those 2 points. Okay? See how they left it? Yeah, they said they wrote it both ways, but so the equation of the line is x minus 3y is equal to negative 10. All right, so that was example 6. Oh man, my hands are cold. This feels so good. So that was in a plane. Well, what happens if we move to 3 space? Not 2-dimensional plane, but a 3-dimensional thing. Well, here we're going to be talking about a volume of a tetrahedron. I don't know if you remember what a tetrahedron is, do you? Tetra usually means 4. So this is 4 points in space. Let's just imagine one's right here, one's over here, one's here, and one's up there. So then draw the lines that connect these points, however it is. You have a 4-pointed figure. Now that's not a cube. A cube has 6 points on it, okay? So each one of these faces is a triangle. From this point, that forms this triangle. From this point, that point, that forms a triangle there. You know, every one of those is a triangle. Weird looking triangles, but they're triangles. Well, that's a odd kind of shape out there, but you got 4 points, anywhere you want to put them, that's a tetrahedron. Finding the volume of that, I don't know any formula that's going to work for you. This does, and it works really, really nicely. And do you ever need to know the points of a tetrahedron? I don't know, but you know, if you ever did, this gives it to you. So the volume of a tetrahedron with 4 vertices, 4 points, and I think you might almost guess how this is going to look. Well, you weren't here for the first part, but it basically looks a lot like that. Here's your 4 points. X1, Y1, Z1, X2, Y2, Z2, X3, Y3, Z3, and X fourth, Y fourth, Z fourth. Okay, 4 points. Now, these are vertices of a tetrahedron. Hint, hint. No 3 of these points, any 3 of them, can be collinear. If they are, you don't have a tetrahedron. Okay? You have one line with a point off of the line. Or certainly not if all 4 of them are collinear. Just isn't going to work. Now this is collinear in 3 space, so it's rather awkward to try to talk about. So what is the volume of that tetrahedron going to be? Well, before we had a plus or minus 1/2, now we have plus or minus 1/6. The determinant, and guess how we do these? We do x1, y1. Yeah. I'm sorry? Okay. All right. Let me mark. Come on here. Okay. I got it out of the book. No, okay. I have made this announcement earlier, but since you're here, you might not go back and listen to the YouTube video to hear it. But one thing that did happen, okay, 2 things. Well, number one, I think I said this to you last time. I don't know if either one of you have classes tomorrow, normally on Friday or Saturday. They're not going to happen this weekend. Saturday is actually Veterans Day, and the state's made the holiday for it Friday. So I'm pretty sure, I know the school is closed tomorrow, and I can't imagine they're going to open it back up on Saturday. So it is actually Saturday. It's what?
They gave a Saturday off work, like paid holiday.
Oh, that's why, yeah. Okay, where do you work?
At Wells Fargo.
Okay. I wasn't sure banks were going to be closed, but yeah.
Well, I work at the call center, so that's why I was wondering why we were not coming to work.
Well, yeah, Saturday's Veterans Day. And the state of Alabama, I think, celebrates Veterans Day more rigorously than any other state in the country that I know of. Now, there may be another, but I don't.
The restaurants are super easy.
Huh?
I said the restaurants are super easy.
The what is?
Like,
oh, the restaurants. Okay, yes. Yeah. I grew up in Georgia. We never had Veterans Day off that I knew of. And I was in Nebraska for several years, at least 5 years. Never had Veterans Day off. I generally didn't even know when Veterans Day was. But then when we moved here to Alabama, I can't remember if my first job had it off. I think they did. But once I've been in the state system, yes. Unless it falls on a weekend, Veterans Day is a holiday. If it falls on a weekend, like Saturday, Friday's the holiday, and I think if it's Sunday, Monday's the holiday. So, yeah, we celebrate Veterans Day here. Okay. Now, you had a very legitimate question. Where does the 1/6 come from? And for the area of a triangle, I could tell you exactly where it came from. And this one, I can't really. So it's just there. Okay, it is there. If you go back and watch the YouTube video, I draw those trapezoids and you add this one and that one, subtract that one from it, and every trapezoid had a 1/2 in it, okay? So that's where the 1/2 came from there. This one is probably something somewhat similar to that, but this is in 3 space, and to see and figure that out, I don't know exactly how to tell you that. Okay. Now, I can tell you this, where the plus and minus come from. Well, you're doing these the determinants, and if you change the order of any 2 rows, you throw in a minus sign, right? Well, a volume is never going to be minus. So whichever way your order turned out being, if it turned out that the determinant was negative, negate it and make it positive. If it turned out the determinant was positive, leave it positive. Don't negate it then, okay? So that's where the plus or minus comes from. The 1/6 is just a feature that you can't avoid, okay? For areas, it was 1/2. I could describe that. For the volume, can't quite do that, sorry, okay? But this is what the volume is, plus or minus 1/6, the determinant of x1, y1, z11, x2, y2, z21, x3, y3, z. Oops, I got off there, didn't I? Got sort of off on my y's too. z31 and x4, y4, z41. Okay, that's just what the volume is. So let's actually calculate one. All right. Yeah, my hands are so cold. I like to hold them just over the fan here, but I can't write anything if I do that. Okay. Here it says, find the volume of the tetrahedron whose vertices are 0, 4, 1, 4, 0, 0. Oh, they're being very nice to us, aren't they? Okay. 3, 5, 2. And 2, 2, 5. As shown in the figure here. Okay. In Buhis, neither one of you have a book with you today, so I guess I need to kind of draw this so you'll have at least sort of an idea of how it looks. And I don't draw 3-space well at all. I don't draw 2-space well at all, but this is really bad. Let's call this our x-axis, this our y-axis, and that our z-axis. That first point is 0 on x, 4 on y, 1, 2, 3, 4, and 1 up z. So it's going to be right back here. The next one is 4 on x, 1, 2, 3, 4, and 0 on x or y or z. The next one is 3 on x, 5 on y. Oh, yuck. Okay. Seems like I was some. There's the second one. The third one was 3, 5, 2. Come out 3 on x, go over 5 on y. So it would be 1, 2, 3, 4, 5. Okay? And then go up 2. 1, 2. Oh, yuck. This has these 2 points looking like they're awfully close together. They're really not. Okay? And then your next one is, do we do 225? I don't guess so. Yeah, 225. Okay. So you come out 2 on X, go over 2 on Y, and then go up 5. Two on X, about 2 on Y, and go up 5. 1, 2, 3, 5. Somewhere up here will be your top one. So it goes down to here, over to there, up to here. Goodness gracious. This is going to look rotten, okay? Nope, I went to the wrong place. I assume that's where I had it. Here, here, here. Okay, that's a pretty ugly tetrahedron. I'm trying to think goodness gracious, these things keep popping up. There's a construction line back here. That connects the bottom here. So it's really bad. The one in the book's better. If you had your book, you could look at that. Okay? So let's label these 4 points. This is 4, 0, 0. This is 0, 4, 1. Okay. This one up here is 225. This one down here is the 3, 5, 2. Okay. Now, that's the picture. It's taking up my whole space. Okay. So I'm going to have to erase all that. So sorry about the ugly picture, but I've got to get rid of it now to do the work. So let's do it. But you get the general idea. So let's get that out of there. And there's your 3 points, 4 points that I don't have to write down again. Okay, there's a few stray dots, and some keep popping back. Okay. Thing keeps getting flatter and flatter the more I write on it. All right, so what's the volume of those 3 points? Will be plus or minus 1/6. Where it comes from, nobody knows. Yeah, but it has to be there. Okay, and you list the 4 points. It doesn't matter what order. 0, 4, 1 with a 1. 4, 0, 0 with a 1. 3, 5, 2 with a 1. And 2, 2, 5 with a 1. All right. I hope I've drawn them right. It looks like I have. And you close this off and make it a determinant. Okay. Now, thank you for having 2 zeros in one row. there's 1 0 in 3 columns, but there's 2 zeros in 1 row, that's what I would go with. Okay? So let's take the second row and do our determinant of based on that row. Okay? All right, that first 4, so plus or minus 1/6. Goodness gracious, this thing won't write. Or erase. Okay? Plus or minus 1/6 times. Okay? First, what's the sign of this position? Nope. Negative. Plus minus. Okay? So that's a minus position, so we make it a minus 4. And then we do, yuck, the determinant of what's left. Ugh. What's left is 4, 1, 1. You wipe out this row too, right? This column. 4, 1, 1, 5, 2, 1, 2, 2, 2, 5, 1. Okay? How do you do the determinant of a 3 by 3? Especially without any zeros in it. We expand and recopy the first 2 columns. 4, 5, 2, and 1, 2, 5. This trick works only with 3 by 3s. Now we go down the diagonal here, and that gives us 8. So it's minus 4 times 8. And you go down this diagonal, and that gives you a 2, plus 2. You go down this diagonal, and that gives you a plus 25. Okay? I'm going to take out those construction lines because they will tend to get in the way of reading numbers. And now we go up the diagonals. Remember? So this will be a minus 4, minus 20, minus 5. Okay? Now, let's see what that turns out to be. Here's a minus 20 and a minus 5. There's a plus 25. Those go away. And that gives you a 8 plus 2 is 10, minus 4 is 6. So this will be, I'm going to go back up here, I think, and do it. Plus or minus 1/6 times a minus 4 times a positive 6. Okay. That's that one. So now I'm going to erase these down here. I don't need, oh, I thought I was going to erase it. This thing has been so bizarre today. There we go. Okay. So erase those. And we'll erase that one. Okay. And we'll go over to this 1 here. What is its position? What's the sign of its position? That 1 at the end. Plus, minus, plus, minus, plus. Any way you get there, it's going to be a plus. So it's going to be a plus 1. I'm not even going to write that down. Times, and then what is the determinant of what's left there? Well, again, we have 0, 4, 1, 3, 5, 2, 2, 2, 5. Okay? Now, because we have a 0 there, it might be a little quicker just to do that. Which row or column you want to use?
First row, first column.
Okay. Give me either a row or a column.
Oh, first.
Which row is first? First row would be okay, or first column would be okay, because both of those have a 0. You prefer the first row? This one? Okay, fine. All right. Then this entry's not going to give you a thing. Okay? Since I'm going to be doing the determinant there, using that row, we'll just wipe it out. but keeping the numbers visible. The 0 is not going to give you a thing. It's going to be 0 times something that's 0. So we'll go straight to the 4. What is its sign of that position? That's a negative. So it'd be a negative 4 times, and when you wipe out that column, you get 15 minus 4, which is 11. Right? Okay. Now, erase that construction line and go to the 1. What is the sign of the position for 1? Positive. And you do its, so that's just going to be a plus. The determinant left is 6 minus 10 would be a minus 4. Okay? I realized I did something. Yuck! This thing keeps shutting down on me. Okay. Alright, plus 1 times, and when you do this, 6 minus, that is a minus 4. Okay? So that's minus 44. Minus 4 is minus 48. Okay? So, for the life of me now, I'm getting okay. So all this was to get what goes up here, which was a plus 1 times this thing here, which is a minus 48. So this will be a minus 48. All right, let's see what we got. Plus or minus 1/6 times a negative 24 minus 48. So that's going to be plus or minus 1/6 times, what's that, 72? 6 will go into 72 12 times. Now that's a minus 72. But guess what? That's gracious. Guess what? Doesn't matter, you're going to lose the sign anyway. That's why the plus or minus out front. So that's going to be 12. So it looks like it's 12 cubic units of whatever. Yes. Well, it came out being a minus 12, so the volume of that tetrahedron is 12 cubic units. Okay? Now, let's go back to the situation I said we had to make sure they weren't. If you're given 4 points in space, the odds are they're going to be none of them, okay, no 3 of them are collinear. Can't swear that, but the odds are that. But if 3 of them are collinear, all of them on this line here, and then 1 more is off the line, what you've now defined as a plane. Okay? Well, that's the volume of a plane is 0. Okay? Not talking about an airplane. This kind of plane. A flat sheet of paper. The volume of that is 0. Okay? Wherever it's lying, the volume is 0. Okay? So, if 3 of these lines are collinear, that means that you have a plane there, then its determinant is going to be 0. Okay? Because the volume is 0. So this now lets you know if you have any 4 points. So let's go back to, this almost looks like that first one that we did. Okay? If you have 4 points, x1, y1, z1, these are in 3 space, x2, y2, z2, x3, y3, z3, and x4, x4, y4, z4. Okay? If you're testing to see if they are coplanar, the only way they could be coplanar or all four collinear is if the determinant that we just did, x1, y1, z1, 1, x2, y2, z2, 1, x3, y3, z3, 1, x4, y4, z4, 1. If that determinant is equal to 0, you know that either these form a plane or they form one strong straight line. Okay? Generally, they'd be coplanar. Okay? If that determinant is 0. If that determinant is not 0, that means you have 4 distinct points and you formed a tetrahedron. Okay? If it is 0, you're collinear. You're coplanar. All these are in one plane. Okay. Now, let's then go to the next application here. What if we only have 3 points? Okay, so we're going to wipe out one of these points, x4, y4, z4. Okay, and we'll wipe out that down here too. But instead of that, we will put another row on top, x, y, z, 1. Okay. To set that equal to 0 would then give you an equation, three-point form of the equation of a plane. Okay? All 4 of those are coplanar, that determinant is 0. Well, what if 3 of them are definitely going to form a plane? If you have a point here, and a point down here, there is one plane that does that. Well, what's the equation of the plane? Rather than having the 4th point there that's on the plane, put x, y, z, 1 as the 4th point, and now do the determinant there. And set that equal to 0. That will give you your equation for a plane. And that's one way to get it. The equation of a plane is that. The next example does that, and I can almost guarantee you we don't have time to do that in 2 minutes. Okay? So we'll pick up with example 8 next time. Okay? Now, that is the last example in the section. Let me give you homework exercises in 3.4. I've given some of these before. Any of the odds 1 through 7. You can do the proof 9 if you'd like to. You can do the proof 11 if you would like to. Then you can do 13 if you'd like. There's a proof 15 if you'd like. Using Kramer's rule, I found these last time, any of the odds 17 to 29. And then more using Kramer's rule, any of the odds 31 through either 31 or 33 or both. Then there's another Kramer's rule, 35. Now we get into the stuff we covered today. Finding areas of triangle, do either 37 or 39 or both. Testing for collinear points, 41 or 43 or both. Finding the equation of a line, 45 or 47 or both. Finding the volume of a tetrahedron, that's 49 or 51 or both. And then testing for coplanar points, we didn't do one like that, but we talked about how to, so you should be able to do that. That's 53 or 55 or both. And then finding the equation of a plane, that's the one we didn't get to do. So you can stop at 55 if you like, and we'll do the rest of those next time. Okay? Now, we're almost through with chapter 3. Okay? So, if you want more exercises to practice on, the review exercises on page 138, there are just to practice on doing determinants, any of the odds 1 through 17. properties of the determinants either 19 or 21. 3, the determinant of a matrix product, 23. Finding determinants of transposes and powers and things like that, that's 25. Finding determinants of inverses, that's 27. Determinants of the inverse of a square matrix, that's either 29 or 31, or both. Solving systems of linear equations, and it says it doing 3 ways: Gauss elimination with back substitution, Gauss-Jordan elimination, or Cramer's rule, okay? 33 or 35, or both. Systems of linear equations, that's 37, any of the odds 37 to 41. You can do 43 if you'd like. 45 is a proof, which you could do if you wanted to. Either 40 and do 47 if you'd like. That's pretty easy, I think, to do. I don't know. Let's see. I think we did Jacobians when we were talking. No, I don't know. Have we done a Jacobian? I'm trying to remember. I don't remember it being in the... I know we did a starts with a W. I can't think of the word though. No, that was in a different class. That was in differential equations. Sorry. No, this is okay. Again, they're introducing something in the exercises, and that's the Jacobian. And so if you want to start looking at that, you can. You can stop there, and we'll pick up the rest of those later. Now, my question to you is, would you like to have your test so you can, if you had time, work on it this weekend? It doesn't officially become your test until we finish the chapter, but we're awfully close. We'll finish it next time, so if you just want to take the advantage of the extra weekend, you can. It's up to you.
I'll take it.
Okay.
I'm going to turn in my other two.
Okay.
Well, both of my two from
This is bothering me because I know I had the copies made. I made the copies. And I had them here last time because I asked if you wanted them. And now I cannot see them. What's that?
How many more sections we have in chapter 3? Like 2 more?
In chapter 3? No, we got one more example.
Oh.
Yeah, we're on the last section. That's why it's just... Okay, here it is. That's why I didn't see it. It says test 2, and it's really test 3. Yeah, that's it. Make sure. That's why I thumbed right through it. Yeah.
Appreciate it.
All right, that's it. And we will pick up and go from there next time. We'll finish chapter 3, and then we move to vectors, chapter 4, which is vector spaces. And that's probably where we'll wind up, because chapter 4 is a long chapter, okay? It has 8 sections. I don't think there's any way in the world we'll finish 8 sections before the term is over, but we'll go as far as we can. Probably your last test will be your final, okay? And it'll just cover chapter 4, as much as we cover. All right.
So I went to where you showed me yesterday, and they just printed me off the same thing that you gave me. So I'm probably gonna have to call Auburn.
Oh. You mean
the transcript?
Okay,
Yeah, they just printed off everything that transferred here.
okay,
So this one.
okay, I'm sorry, I thought that's what I had forgotten that I had already printed that for, I thought that's what you were asking for. Go around from where that was, just keep going up that hallway until you get to the windows, turn around, and that's the admissions desk.
Okay.
Ask one of the ladies there at the desk if you can get a copy of your transcript that Auburn sent here.
Okay.
They have access to that. I'm sorry. I thought the records office would have it too.
Yeah, that's what I asked her, but she didn't tell me that either. So I'll go to admissions and ask them.
Yeah, and ask them, and it may be that both of those people can't access that, but one of them should be able to. So if there's only one person out there, now I'm not counting work study students, they have work study students out there sometimes too, but if one of the regular ladies are there, one of them I think can access, probably both of them can, but I know one of them usually can access the transcripts that were sent here from Auburn, so you can see if there's another course on there that should have been counted. Okay, yeah. Sorry about that. I sent you the wrong place probably.